Welcome students. In this video, I am going to discuss parabola. Now, a parabola is the set of all points in the plane that are equidistant from a fixed line and a fixed point, and that point should not lie in the line. Suppose here I have taken a fixed point, say F, and then I take a line, fixed line L. Now, I take a point P1 and the distance of P1 from the focus is same as that of distance of P1 from this line L. Then I take another point, say P2. Then the distance of P2 from F is same as that of distance of P2 from L. Take another point, distance say P3. Now the distance of P3 from F must be equal to distance of P3 from line L. The curve described in this way. This P3 here. The curve described in this way is called the parabola. Like here, distance of P1 from F, this P1F is equal to P1B1. Then distance P2F is equal to P2B2. Then P3F is equal to P3B3. The fixed line, this fixed line is called the directrix of parabola, and the fixed point is known as the focus of parabola. The next, the line through this focus and which is perpendicular to directrix. This is your directrix fixed line. The line through the focus and it should be perpendicular to directrix is called the axis. This is the axis of parabola. Next, the point of intersection of this parabola with the axis, this point. This is called the vertex of parabola. Now I am going to discuss some standard equations of parabola. In your syllabus, you just deal with the standard cases. The equation of parabola is simplest if the vertex is at the origin and the axis of symmetry is along x-axis or y-axis. The word symmetry I'll discuss later. Just look at the first case. This is your x-axis and y-axis. This is your vertex, origin. Now, if you look here, the focus is on x-axis. So this is A0. This is your first case of parabola. Open towards right. Its equation is y square equal to 4ax. The focus is on the x-axis. So its y coordinate is 0. This is A0. Now the distance of this point, this is your origin from focus and this is also your vertex. From F is same as that of distance of this O from directrix. Now this is the line. That means this distance must also be equal to A. And this is to the left of origin. Is a line which is parallel to y-axis. So its equation is given by x is equal to minus A. The focus A0, directrix, x is equal to minus A. Now the focus is along x-axis. So the axis of this parabola is x-axis. This parabola is symmetrical about x-axis. You can check. जितना रीजन आपका एक्स एक्सिस के ऊपर है सेम रीजन इज बिलो द एक्स एक्सिस. So that means this is parabola. This parabola is symmetrical along x-axis. You can also check if we replace y with minus y and the equation remains same. Like here you have minus y whole square. It's 4ax. Negative square, this is positive. So you'll have y square is equal to 4ax. If you replace y with minus y, the curve remains same. That parabola will be symmetrical along x-axis. The second case, open towards left. Its equation is given by y square is equal to minus 4ax. Again, this is your vertex. V, you can also write here V. This is at origin, 0, 0. The focus here, so this is minus A0. Directrix, same if this distance is A, this also be equal to A. It's a line which is parallel to y-axis. So its equation is given by x is equal to plus A. Again, the focus is along x-axis. So the axes of parabola are also x-axis. And this parabola is symmetrical about x-axis. The portion above the x-axis is equal to the portion below the x-axis. Or you can also check. Replace y with minus y. The curve remains same. So this is going to be symmetrical along x-axis. The third case, open in the upward direction. Again the vertex is at 0, 0. Open in the upward direction. Its equation is given by x square is equal to 4ay. Now, here the focus is on the y-axis, so its coordinate must be 0a. Directrix. Same distance a here is a line parallel to x-axis, so its equation is given by y is equal to minus a. Focus 0a, directrix y is equal to minus a. Vertex 0, 0. Focus is on the y-axis, so the axis of parabola are along the is our y-axis. Now, this parabola is symmetrical about y-axis. The portion on the left and on the right hand side of y-axis is same. So this is going to be symmetrical along y-axis. If you replace with, or you can check, you replace x with minus x, the curve remains same. So this parabola is going to be symmetrical about y-axis. The fourth case, open in the downward direction. Its equation is given by x square is equal to minus 4ay. The focus, the vertex also here at 0, 0. We are dealing with the standard cases. In all four cases, the vertex is at the 0, 0. X square is equal to minus 4ay. The focus 0 minus a. Directrix parallel to x-axis. Its equation is given by y is equal to some constant. Here constant is a. Axis. The focus is on the y-axis. So axis of this parabola is y-axis. Also this is symmetrical along y-axis. The latus rectum. Latus rectum of a parabola is a line segment. In all four cases is a line segment perpendicular to the axis. This is your axis because here focus is a line segment. This line segment perpendicular to the axis through this focus and whose end point must also lies on the parabola. I am repeating, latus rectum of a parabola is a line segment which is perpendicular to this axis through the focus and the end point are also on the parabola. Is called the latus rectum. Here this AB is the latus rectum, right? Now this parabola clearly is symmetrical along x-axis. So AF is equal to FB. That means your AF is equal to FB. So this AB is equal to length of latus rectum is twice of AF. Because this is symmetrical along x-axis. So AF must be equal to FB. That means AB. You can write your AB as twice of AF. Next, A point is on the parabola. So by definition, distance of A from the focus must be equal to distance of A from this directrix. Clear? So, now this distance, this length is A. This is also A. That means this AF must be equal to AC. AC is A plus A. AC is 2A. So, AF must also be equal to 2A. So, here put the value of AF. 2 of 2A. So, answer is 4A. In all four cases, the length of latus rectum is equal to 4A.